Hi everyone, this is Sunny Kumar from Mathematics and Computing Part 2 from IIT BHU, and I am back again with February easy problems. And today the problem is a vertex set. Okay, I'm going to discuss the solution of this. So basically this is the problem of dynamic programming. So in this question we have been given a tree with n nodes, and note that the tree is a rooted tree with root at node equal to 1, node 1, and each node holds some value that is going to be denoted by the array A, and we are defining a set X that is a subset of the node from n nodes such that it is going to vary from V1 up to Vk. Note that there is a condition for the set X, that is there must not be exist an edge between any two vertices in X. So what could be the possible condition? So the if V1 is going to be this, let's say node 2, then our any other pair in the set X can't be any of the child of these two or the parent of these two. So any consecutive nodes, that is 02, 04, 43 or 25 or 21 can't be in the set X simultaneously. Okay. So also Fv is the maximum value node present in the subtree of node V including itself. So what is the value, what is the meaning of Fi? So Fi is basically the, suppose let's say F2. F2 is actually the maximum value of all the nodes, that is maximum value of all the node values present in the subtree of that node. That is, we have to take maximum of node value of 1, that is node value of node 1, node value of node 5, node value of node 2, and store that maximum into the subtree, into that node 2 itself. Okay, so that is what Fi is going to denote. Now we have to maximize the value of Vx. So what is Vx here? So Vx is the sum of values of Fi varying from I equal to 1 to I equal to k, and where these are values of fv1, fv2 up to fvk. So how we are going to do this, how we are going to approach this question, let us understand this. Okay, so what would be our approach of this question? The approach of this question is dynamic programming. Why the approach is going to be dynamic programming? So let me write here why. So our reason would be simple: we have to either choose or eliminate the node value. Okay, let me either choose the or eliminate the node value. So our first approach would be, we are going to first calculate the value of fv, that is the maximum value node present in the subtree of node v itself. Okay, so how we are going to do this? We are going to do this using DFS, depth first search approach. Okay, so for this let us move on to the code section. Okay, so as you can see here, what I am going to do is I am going to pass a current node V and a parent P and the adjacency list, as you can see here. Now what I am going to do is I am going to use the depth first search to find the maximum value of the subtree of node, current node, including the node itself. So if the current node equals to the parent node in the adjacency list, I am going to continue further such that no operation further can be done. So first I am going to use the depth first search after this and store the maximum value in mx. Note that mx is initialized with the current node's value. So finally I am going to store fv as maximum value of that subtree and going to return this mx. So f is going to store the maximum value of all the nodes of that subtree. Okay, so after doing this, our our f array would contain the maximum value of all the nodes. Okay, so note that also, let me explain. Note that our set X would be would contain the nodes in such a way that there does not exist an edge between any two vertices in X. So the vertices must not be consecutive in the tree. That is, suppose we have chosen the node 2, then our any pair would not contain, in our set X should not contain 0, 5 and 1. Okay, now moving further, we can say we are using to dynamic programming from the bottom up approach. That is, what we are going to do is, suppose initially we are going to initialize the base case of DP same as the found maximum values at each node, and what we are going to do is for the current node, let me write here. Okay, for current node, either choose, okay, either choose the current node and sum of the grandchildren nodes, or we are going to choose sum of all the children nodes. So why you are going to do this? Because note that the our set X does not contain any edge common in between them. That's why we are going to choose either the current node. Okay, let me explain with graph editor. Suppose we are going to choose this current node, then our suitable approach according to the question, according to the statement that we should satisfy to the question is, if we are choosing this current node, then our set X must not contain the nodes having that edge, so we cannot choose 2 and 4. So the optimal approach would be choosing either 1, 5 or 3. So for the current node 0, we are going to choose the sum of the grandchildren values plus the current node. So our the current state of the DP would be maximum of sum of grandchildren values plus the current node, or there is one more thing that we can say, if we are using a bottom up approach, so our answer up to the current level starting from the bottom would be, for the current node, either we are going to choose this node and the sum of grandchildren values, or suppose we are not going to choose this value, so our answer would be the sum of the children values. The state of the DP is similar to like, okay, suppose we have an array separated like this. So our let me say here it is 15 for understanding. So for choosing 15, so our answer up to the 15 values would be, either we can choose 15 or we are going to eliminate this 15 and choose the values up to this if it is giving the maximum value. So here also we are, what we are going to do is, the maximum value up to this node would be, either we are going to choose this node or we are going to eliminate this node. So if we are using this node, then we are going to take the grandchildren values, and if we are not choosing this node, then we are going to choose the sum of the children values. Okay, so the question becomes simple using the help of dynamic programming. So what I'm going to do is, I'm going to move further to my code section. So let me understand. Okay, first I've taken the test cases. So n is going to represent the number of nodes, and there is a adjacency list I'm going to represent with adj. Okay, note that I've taken the values. I've used the indexing format is starting from 1, and there is an undirected graph I have taken. So initially I have initialized all the values fi with the node values, and I have called the dfs function with parameter 1, that is going to pass the rooted node, and -1 as this parent and the adjacency list. And what this dfs function is going to do is, dfs function is going to store the maximum node value in that subtree in the array f. Okay, now I'm going to initialize my base case of the dp with maximum value, that is fi. Note that what I am going to do is, I am going to apply the dynamic programming from using the bottom up approach, that is starting from the leaf node and moving further. So for any node we have two choices, either use that node or do not use that node. Finally I am going to print dp of 1, that is our answer at the root node. So let me move to the functions. So I have already discussed this function, which is actually using for calculating the maximum value of that subtree. You can find in my description section of the video. Also you can see here I have dfs1 function. So what is this dfs1 function is going to do here? Now you can see I have initialized a variable x and y. X is going to store the sum of values of the children nodes of the current node, and y is going to store the sum of the values of grandchildren nodes of the current node. Okay, now what I'm going to do is, I'm going to traverse in the adjacency list of the current node, and if this the current node, that is the children node, is going to coincide with the parent node, I'm not going to move further. So if this doesn't happen, what I'm going to do is I'm going to take the sum of all the children values, children nodes values, note that, okay, and this x is going to store the sum of values of children nodes, and y is going to store the sum of values of grandchildren nodes. So our current state of the DP, if we apply the bottom up approach, would be either using that node or eliminating that node. So if we use the current node, that is our answer would be the current state of DP plus the sum of grandchildren, sum of the values of grandchildren nodes, okay, sum of the DP values of grandchildren nodes. Or if we eliminate that node, then our answer up to this node would be x. So I'm going to take maximum of both and I'm going to store in the current node, okay. So this is basically the bottom up approach of dynamic programming in the tree. So the question becomes somewhat tricky. So if you have any doubts, do mention in the comment section of the video, and I recommend users to like my telegram channel, join my telegram channel. Also, if you have any doubts, mention in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to my YouTube channel. Thank you for watching this video.